Right, we are moving on here to section 9.3, which is the unit circle. Going to define two vocab words to start with, and then talk about what the unit circle is and how we're going to use it here in Algebra 2. First thing we're going to hit on is reference angle. Reference angle is an important vocab word. That is a positive acute angle, which is located in quadrant 1, and it is the distance between the angle that you are at and the x-axis. We're going to talk about that in the second part of the notes. Unit circle, we're going to talk about in the first part of the notes, is a circle with a radius of 1 centered at the origin of a coordinate system. So if you are in the unit circle, one of the characteristics of the unit circle is that your radius of that circle is always going to be 1. Here is a filled-in unit circle. And as you can see, there is a lot going on. You have a lot of different numbers, a lot of different coordinates, and kind of just looks like a big wheel. So we're going to kind of break this down as quickly and efficiently as possible. There's a lot that you can do with the unit circle, and once you get up to pre-calc, you will be doing a lot more with it. And Algebra 2, we kind of just touch on it, go over some key characteristics, and then kind of stop there. Couple of things that are review though. In the unit circle, you have degree measures, and we started off unit 9 talking about how to calculate degree measures, 30 degrees, 45, 60, 90. And then in the 9.2, we talked about how to convert degrees to radians. So you have degree measures, which I now have in green, and you have the corresponding radian measures, which I now have in purple. So again, you can use this to kind of help you evaluate between or convert between degrees and radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians, so on and so forth. Over here in the red box, a couple of really important things. Number one, cosine is a trigonometric function. And if you are in the unit circle, the cosine value is the x-coordinate. Sine is the other important trig function. The sine value, S-I-N-E, is going to be your y-coordinate. And the third trig function that we're going to be talking about is tangent. And your tangent value is going to be y over x. Now, when you see x and y, you might think, okay, what does that mean? Around the entire circle, you have coordinates, which I now label in blue. All of these are coordinates at specific locations. Okay, so if you remember back from coordinates, coordinates are pretty easy. Coordinates, your x value is first, and your y value is second. So you have cosine and sine of all of these specific angles throughout your unit circle. In addition, on the complete outside of the circle are the tangents. So all of the purple values, generally sometimes you guys have to calculate these, but because of the situation and that we're kind of online here trying to simplify the work a little bit, I have given you all of the tangent values. So generally, if you were going to find tangent without the purple numbers, because in the normal unit circle, the purple numbers are not on the unit circle, I just added those in there. You would have to do y divided by x to calculate tangent. Okay, so again, a lot going on in the circle, a lot of numbers. Biggest thing is just to try to stay organized. You will be given an angle and a trig function, and they're going to ask you what the value of the specific trig function and angle are. Okay, so over here in example 1, cosine of 30 degrees. Okay, so the first thing is you have to first figure out where 30 degrees is in your circle. 30 degrees is right here. And then they want the cosine at 30 degrees. Okay, so then you go back up to your table here. cosine is the x-coordinate. So you know you want to be evaluating at 30 degrees. 30 degrees is right here. Then you go up to your coordinate. The x-coordinate is cosine. The x-coordinate at 30 degrees here is square root of 3 over 2. So the cosine of 30 degrees is square root of 3 over 2. Okay, it's kind of like a puzzle. You find the angle, you figure out if it's cosine, sine, or tangent, and you find the corresponding value at the specific angle. Second example, tangent of 11 pi over 6. Okay, so now the angle is given to you in radians because you have 11 pi over 6. Okay, similar situation. First have to find 11 pi over 6. 11 pi over 6 is down here. I know I kind of wrote over this, but without all my highlights, 11 pi over 6 right here. I want the tangent, and tangent is the purple number, purple value. So at 11 pi over 6, here is your tangent value, which would be negative square root of 3 over 3. Okay. So there's a bunch of examples in here. I'm just going to go through a few of them. Let's do number 2, number 3, and number 7. So cosine of 7 pi over 6. So a little recap here. Cosine is x, sine is y, tangent is y over x, or in this case, the values in purple because they're all on your unit circle for you. Okay, so if you were starting from scratch and you had a blank unit circle, which you guys remember in the email that I sent you with the video link, there is a blank copy of the notes. So you can use your unit circle here. And I need to do the cosine of 7 pi over 6. Okay, so first step is to find 7 pi over 6. You go around your circle. Here is 7 pi over 6 over in quadrant 3. Okay, then you have to remember cosine is x. So you find the x coordinate. Remember, x is always first at 7 pi over 6. The x coordinate, negative square root of 3 over 2. So your cosine of 7 pi over 6 is negative square root of 3 over 2. Number 3, sine of 240. I'll do this one in blue. Sine of 240. Find 240 degrees in your circle. That's right here. Remember, your sine value is y. So you go to 240 degrees. You find the y coordinate, which happens to be the same thing, negative square root of 3 over 2. Fourth one, tangent of negative 45. Do this one in green. Okay, now, negative 45 is not technically on the circle that you see. So if you remember from 9.1, you need to figure out where negative 45 degrees is. And since it's negative 45 degrees, you have to go down first. So again, finding angles, start at your positive x-axis, the initial side, and I need to go down negative 45 degrees because remember, negative 45, you go down first. And again, you're not going to see the number negative 45 on your circle. So you're going to come down 45 degrees until you get to right here. This little spoke, if you want to call it, this is a negative 45 degree angle. Okay, so negative 45 is in the same position as 315. And if you remember coterminal angles are 360 apart. And since negative 45 and 315 are 360 apart, they're coterminal. That's why they're at the same spot. Okay, I'm doing tangent So if you remember, tangent is your purple value. Your purple value at negative 45 degrees is negative 1. So your tangent of negative 45 is negative 1. Okay, I'm going to do one more. Number 5 here. I just noticed it. We did this one in purple. Okay, students tend to struggle with these numbers that are get bigger or that are quote unquote not on the circle. Okay, so number 5 says cosine of 390 degrees. Okay, so a common question that I would get if we were in class would be, Mr. Heitens, 390 degrees is not on the circle. It only goes to 360. Correct. Visually, the only thing that is on the circle, it goes up to 360. But imagine that it's a circle. It can keep going and going and going and going. So pretend you start here, and you need to go to 390 degrees. So you go 90, you go 180, you go 270, and you go 360, and you get back to where you started. Well, keep going. You got to go to 390, which is 30 degrees farther. So if you were going to go all the way to 390, yes, you have to go around the circle more than once. You're going to go all the way up and you're going to stop right here. Because if you stop right here, think about what I just drew. I drew a 360-degree circle plus another 30 degrees. And 360 plus 30 is 390. So I'm going to end up right here. This is 390 degrees. I am calculating cosine. Cosine is my x value. So I go to 390 degrees. I look at the x coordinate, which is square root of 3 over 2. And that is my cosine value. Okay, so remember, you are in a circle. You can go around more than once. You can go around more than twice. You can go around as many times as you need to, and you can go backwards. If you go backwards, you're going in the negative direction. So be careful with the ones that you don't see on the circle. You got to kind of think about, okay, if I kept going around the circle, where would I end up? Let's see. I'm going to skip down here to reference angles to save some time. Okay, reference angle is the distance between the angle and the x-axis. Always positive. Okay, so reference angles, generally, you only have about 4 options for answers. Your answers usually are going to be 30, 45, 60, or 90. So to kind of help you guys a little bit, generally those are going to be all your answers are going to be either 30, 45, 60, or 90. Okay, this is a kind of a tricky concept to remember. The biggest thing is you can only use the x-axis. So I'm going to emphasize that kind of in my few examples here. So the first thing you're going to do is go find the angle that's given to you. Okay, so a little review here. Remember, this is a Greek letter theta, which is the central angle. So anytime you see that symbol, that means angle. They're going to give you an angle, and they want the reference angle. Okay, so first thing I'm going to do is find 5 pi over 4. I'm going to go down here to my unit circle. I'm going to find 5 pi over 4, which is right here. So this line right here is 5 pi over 4. Okay, so I like to just draw triangles. Here's my 5 pi over 4. And remember, this is your x-axis. So the reference angle is the distance between where you're at 5 pi over 4, and the x-axis, which is right here. So if you think of the x-axis and the angle you are at, you have two rays, you're going to create an angle. The question is, what is that angle? Okay, so they give you some hints. This is 180. This is 225. So what's the difference between 180 and 225? Well, all it does is turn into a subtraction problem. 5 minus 0 is 5. Let's see if I can remember how to subtract here. 45 degrees. So this angle right here between the x-axis, this is your x-axis, and the angle that's given is 45 degrees. That is your reference angle. Always positive. Oops. Okay, second one. Negative 135. Okay, so again, now this is one that can be a little tricky. And the most common question I get is, negative 135 is not on my circle. Well, correct. It's not written on your circle, so you need to go find it. So again, if you're finding angles, start at the positive x-axis. Now I need to go find negative 135 degrees. Here's negative 90. And then I need to go 45 degrees more. So I'm going to go over to here. This would be negative 135. Okay. Now, again, here's a common mistake. If you're doing reference angles, a lot of students will find this angle right here. They'll say, oh, okay, I'm going to find this angle right here. Okay, if you think about that, that looks like it could be right, except when you draw this ray in right here, you are using the y-axis. You can never use the y-axis. This is the y-axis. You can only use the x-axis if you're doing reference angles. So you got to back up. Don't do that. Okay. Again, this was negative 135 degrees. But now I need to use the x-axis, which is right here. This axis and wherever your terminal side when you stop to make the 135. And if you notice, this is the same exact problem I just did. Okay, the x-axis is 180. You are at 225, which means this angle between my two red lines is 45 degrees. So your reference angle would be 45 degrees again. I'll do one more. 330. Okay, so again, go find 330 degrees. I'll start over here, delete all this. 330 degrees. This one's on your circle. 330 degrees happens to be right here. This is the ray or the terminal side at 330. Next, go find the x-axis, which is right here. And I need to calculate this angle. So this is 330, this is 360, 360, 330. The difference between 360 and 330 is 30 degrees. So find your angle, find the x-axis, subtract the two, and your answer should be 30, 45, or 60 every time. So this one would be 30 degrees. Number 5. The angle measures associated with which set of ordered pairs share the same reference angle? Okay, so they're going to give you two coordinates, and they're asking you which ones have the same reference angle. Okay, so your first job is to find all of these coordinates and where they're at. So letter A, I'll do this in green. -1/2 square root of 3 over 2. That's right here. And then a square root of 3 over 2, -1/2. That is right here. And I have to see if these have the same reference angle. So here's my first coordinate. Here's my x-axis. This is 60 degrees. Here's my second ordered pair. Here's my x-axis. This is 30 degrees. Those do not have the same reference angle. Okay, then I'd have to go try B. 1/2 negative square root of 3 over 2. And negative square root of 3 over 2, -1/2. That's not going to be right. C, -1/2 square root of 3 over 2, 1/2 negative square root of 3 over 2. All right, so let's look at C. C I'm going to do in blue. So again, all I'm doing here is I'm finding the given coordinates, and I'm looking to see if they have the same reference angle. Okay, so C, -1/2 square root of 3 over 2, that's right here. And then 1/2 negative square root of 3 over 2. That is down here. And now let's calculate reference angles. This top one I just did, this is my first coordinate, x-axis. This is 60 degrees. Here's the second coordinate, x-axis. This is also going to be 60 degrees. So these two coordinates in blue both have reference angles of 60 degrees. Therefore, they have the same reference angle. So your answer would be C. Let's see. Which expression is equivalent to sine of 240? Last one. So this goes back up to the first concept we did. Sine of 240. Okay, let's remember what sine is. Sine is my y value. So I'm going to go to 240 degrees, which is right here. Find the y value, which is negative square root of 3 over 2. So the sine of 240 is negative square root of 3 over 2. So out of my 4 multiple choice options, I need to figure out which one has a y coordinate of negative square root of 3 over 2. And if I do this, I believe it's going to be D, sine of 300. So if you follow that same procedure and go to 300 degrees, 300 degrees is right here. Your y coordinate is a negative square root of 3 over 2 at 300 degrees. So therefore, these two y coordinates are the same, which means the sine values are equal.